Welcome back. This is the last problem on the concept of stoichiometry. Now, I've made it literally simple. If you spend about 30 minutes of your time in 1 week, you can watch all 4 videos on stoichiometry, and literally I've condensed it to a small ball that you can handle, okay? And in the process, I have literally covered everything you also need to know. I didn't leave out any minor detail. I've covered everything. And if you remember in the introductory slide, I said there's a case where students seem to, if they have understood the idea of stoichiometry, they can do it forward. Working a problem backwards just doesn't seem that easy. All right, so at this point, I've explained all the terms. So this is not a new concept. This is just a different way of looking at one of the 3 problems we've done. In the 3 problems I have done on this concept up until this point has literally taught you the idea of stoichiometry, right? This is not going to teach you anything new. This problem is just going to help you work the problem backwards. Now, what does that tell you? There's a high chance that I might test you this concept of working backwards, which is why I'm doing it. So I'm going to load the problem. There's 2 questions to this single problem. Before you do anything else, you got to know how to balance your chemical equation. And we've already balanced it. And I remember right that I think this was what was on the first problem. So you still need to learn how to balance a chemical equation. Now it's asking how many moles of N2O5 were used. It's asking how many moles of N2O5 were used if 2.5 gram of NO2 is produced. This is actually very simple. You do not even have to worry about which is limiting or excess. You just have to work the problem out, just like you would do any other problem. So you're given 2.4 grams of NO2, right? That's your given information. You see, I'm being consistent with the way I use terms. 2.5 gram of NO2 is seen in the question. That's your given information. It goes there. And NO2, you cannot go from grams to moles without actually going through molar mass. Nitrogen is 14 and 2 oxygen is 32, so it's 46 grams over 1 mole. This is the molar mass of NO2. Okay, so 46 grams goes on the bottom, 1 mole goes on the top. Now this is for NO2, right? Now it's asking for moles of N2O5, right? We are currently at moles of NO2. How do we go from moles of NO2 to moles of N2O5? You guessed it right, mole ratio. What's the ratio of NO2 to N2O5? Is 4:2. 4 NO2 goes on the bottom because why? Because we have to cancel out NO2. 2 N2O5 goes on the top. So that's all the question is asking. Moles of N2O5 would be, well, you can just do the math. 2.5 over 46. Basically divide by 2. That's 0.0271 moles. That's it. Let's do this one. It's asking how many moles of N2O5 were used if 1.5 gram of O2 is produced. Again, that's the given information. So 1.5 gram of O2 over 1. Molar mass of oxygen is 32 grams over 1 mole. This is again for O2, but we don't want O2, we want N2O5. You guessed it right. You got to use the mole ratio of O2 to N2O5. That's 1:2. So for 1 oxygen, we have 2 N2O5. Again, you see everything cancels out, right? Nothing, what we want is the only thing that should be left. So 1.5 over 32 times 2 would be 0.093 moles of N2O5. Now let me hypothetically extend this question. This is where the problem ends. Okay, we're done. But what if I ask you, which of these 2 is limiting? That is, imagine we're going backwards, right? So is NO2 or O2, which one is limiting? This is hypothetical. How do we know something is limiting? Is the smallest of the two, and the smallest of the two is the top value, and that value comes from NO2, right? So NO2 is limiting, right? That's it. And that means the other one, O2, is excess. Hypothetically speaking, right? Although that's not in the question, this is extension of knowledge, right? Very good. And that's pretty much it. We can continue this problem, but I think this is good enough. This is where I want to stop. And that's all there is I have for stoichiometry. So watch the videos. They're fairly quick. Shouldn't take you very long. And if you have questions, you will ask me that in class, and I'll be able to answer them as well. So stay tuned.